Welcome to the Getting Started with Docker course. In this course, we're going to cover what is Docker, what it's all about, how to use it, and how to make best use of it. Now, in this particular video, I'm going to introduce you to Docker, tell you what it is, how it works, who should use it, and then what the rest of this course will cover. So let's get started. So what is Docker? This is my definition. Docker is an application packaging solution to make software deployment easier. Now, there's a lot to it, but at the heart of it, it really is a way to package up your application in a way that makes it very, very easy to deploy. So let's talk through how Docker is structured. And it is going to take a little bit to kind of understand and better grasp. So you may be wondering, what is Docker in a more, complete sense? We'll get there. But let's talk through in different ways to try and get at what this Docker is and how it works. So how is Docker structured? So Docker is structured with layers upon layers. Think of it in terms of software development as dry. Don't repeat yourself. And so everything Docker does is about eliminating repetition. So for example, if you have an application that, let's just say, uses a Linux operating system underneath, well, Docker already knows what Linux is all about. And so it has that in its core structure. But then, if you want a particular type of Linux, we just add a layer that adds those particular additional features on top. And then on top of that, we build some more layers for this piece you need, like a web server, maybe Apache. So you add that on top of the previous layer of the additional Linux features you needed based upon the previous layer of base Linux. So it's layer upon layer, and the top layer or the top layers are your application, which is your application, all of the dependencies, and anything else that is connected with your application. So it's layer upon layer. Now with that, each of these layers, we create read-only images. So what happens is when we create, let's just say we're creating our application itself, or an image of our application, it builds that layer and it makes it a read-only layer, which then allows us to be sure that our application will be the same today as it is tomorrow. It'll be the same on our machine as it is on someone else's machine because it's a read-only image. Okay? And then every image has, when we turn it into a container, and we'll talk about these terms in a minute. When we turn it into a container, it creates common interface points. So we talk about containers with Docker because that's the image that the Docker people have created. And it's the idea of shipping containers. The idea that every shipping container is structurally the same on the outside. It has the same points for grabbing onto it. It has the same basic size, width, and height, so that it can be used by any different crane on any different dock in the world, or a different trucks and trains. All those things can depend on this common interface points. Well, in the same way, our applications, when they're packaged up into an image and then turned into a container, that container that has our application will have common interface points so that any machine in the world can run it. Whether you are local on your own machine, whether you're running Linux or Windows, or Mac, whether you are deploying to Azure or AWS or Google's offering or some third-party offering, those common interface points allow us to interact with a container the same exact way every time. So you have a read-only image that is never changing, and It has the same interface points. That means it's very easy to work with Docker, and you're getting the same experience every single time. So that leads right into the benefits of Docker. And the first one, instead of it works on my machine, it works on every machine. So, when you're building software, one of the big downsides or trouble spots that you run into is that when you are building your software, it runs great on your machine, and you go to deploy it, and it doesn't work somewhere else. And that's a problem. So instead, with Docker, we can deploy it anywhere, and it will work the same way on every machine. That's huge. Next, we can recover quickly from failure. So with Docker, because these read-only images exist, and because we can set them up so that they're on any machine you want to then rapidly spool up a new machine, even if the worst case happens and your Docker container blows up in some spectacular way, which doesn't happen often, but just say it does, well, you can just spool up a new Docker container in seconds and be right back where you were, as if nothing happened. So very quick recovery from failure. Deploys anywhere. We've already talked about this a little bit, but the fact that you can take your environment and say, you know what? Today, Azure is a great deal. And so you deploy all your containers to Azure. And then tomorrow you find out, wait a minute, AWS is going to offer me something better. I can move all of my stuff over and it just works. There's not a infrastructure specific to Azure versus AWS that would cause me to not be able to move my stuff. Easy scalability. This is great because when you want to scale your application, you don't want to have to worry about configuring new servers and making sure that the options are all set up properly and making sure that the web server is properly aligned or whatever it is. With Docker, you don't have to. You want one container? Great. There's one container. If you want 100 containers, it's based off the same image. They can pop up almost instantly. So very easy scalability. And it's fast. One of the comparisons that Docker gets a lot is a comparison to virtual machines. And it's not a virtual machine. And that's part of the confusion here, is that Docker is both less than and more than a virtual machine. It's less than in the fact that you out very easy to work with. And this one is one that's often missed, but this is a really solid way to create a test environment on your machine. Sometimes it's hard to set things up properly to simulate what you're going to have in production. Because in production, you may have a Linux machine, but you're working on a Windows machine in development. Well, how do you simulate that? In fact, that's what I do. I have a Linux Docker setup, even though I'm working on Windows. And so we'll walk through those options. But this allows you to scale up and have multiple machines or multiple Docker containers running with things like SQL or VS Code or your different production applications on your machine where you can test things out as if they were in production and have them react the way they would in production, but it's all local. So definitely a solid test environment. So that's a lot of benefits for Docker. Let's talk through the key terms. I've used some of them before. I want to make sure that we're very clear on what these things are. We'll cover more of them in the course, and we'll cover them more in depth in the course. But let's talk through the key terms. So the first key term is an image. And like I said before, this is a read-only snapshot, or a read-only, well, snapshot's probably a good term. A set of code or a set of DLLs and EXEs, whatever it is, it's a set of files that you say this is a layer. And you can have multiple of these that stacked on top of each other, but then you say this layer or this grouping right here is my application. And then that's read-only, which may sound like, well, how do you use a read-only image? Well, the image itself is read-only, and that's what you use to create a container. You don't actually use the image directly. Think of it like we used to, and maybe you haven't done this before, but we used to create an image of our operating system so that if the computer ever crashed, we could put the disk in or put the thumb drive in and restore it back to a certain point in time. That's basically what we're doing here with images. This is a point in time with our application. This is where it is in version 1.0.0, for example. And then if we want to create a 1.0.1, we create a new image. Now the next term is container. A container is built off an image. And the container is where you actually run your application. So when you run a container, it is based off an image and it will do the operations as if it were a full operating system internally. So for example, if you wanted to host a web application, you would have the web application and the web server and all the connection points for the operating system all in your container based upon the image, and you would be able to turn that web server on, interact with it both from your machine and other machines, and then if it got corrupted or if there's a problem where you somehow you had a bug in your code or maybe you got hacked and files were deleted, not a problem. You turn the container off, you start it a new container from the same image and bring it back up in its place in seconds. So that's a container. A container is where we actually see the working version of our code. The host. So the host is what's actually running Docker. So in this course, the host will be my personal development machine. That's what's running Docker. And then on the host, I can have multiple images and I can have multiple containers running. When we're talking about virtual machines, again, this is not a virtual machine, but it's a similar concept as far as the host versus the container, where if you're running virtual machines, you have your machine with a hypervisor, and then you have on it multiple virtual machines. Well, in the same way, I have my host machine, and then on it multiple running containers. The difference is there's a lot less overhead with containers. Containers don't take up nearly as many resources as far as space or as far as speed. All right, the next key term is the Docker Hub. So the Docker Hub is the central place where all of these base images live. So if you want to get an image, for example, we're going to use an image called HTTPD, which is essentially a Linux distribution that has Apache on it. Apache is a web server. Well, someone's already created that and put it on Docker Hub. All I need to do is go out to Docker Hub and pull it down. You'll see how to do that in the course. So Docker Hub is a central place to get common images. Microsoft has a bunch of images up there for their various setups. So .NET and .NET Core and different things like that. Okay, frequently asked questions. These are questions I get quite a bit about Docker. The first one we've kind of covered, but is Docker creating virtual machines? And the answer is no. A virtual machine has a full operating system running on it, which means that if an operating system needs, let's just say, 2 gigabytes of RAM for the normal operating system stuff, we don't need that in Docker. If an operating system needs, let's just say, 500, not 500, 5 gigabytes worth of space in order to have all the different operating system files, we don't need that with Docker. All we need is a little bit of additional overhead for the storage of anything above the base operating system that we need. Okay, so it's a shared operating system, but yet it's still isolated per container. So it's not a virtual machine. It's way faster and leaner. So where can I use Docker? Well, Docker can be used all over. And that kind of leads to the next question as well. So let's cover both of them at the same time. What operating systems does it support? So I can use Docker on Windows, Mac, and Linux. Basically all the major operating systems. The operating systems that run on Docker are Windows and Linux. So if you need to run a Windows machine in Docker to have your software, for example, if you have a .NET framework application, you need a Windows image. Whereas in this course, for the vast majority of it, I think most of it will use Linux containers. Even though I'm on Windows, we'll use Linux containers and do so with both a straight web server as well as an ASP.NET Core web server. So we'll use Linux for that. So it's either Windows or Linux for the operating system. As far as where we can use Docker, it's Windows, Mac, and Linux. So basically everywhere. So who controls Docker? And that's a great question, because you want to know, well, is this a Microsoft controlled thing and they kind of holding the reins on this, or is this somebody else? Docker is open source. Docker is not controlled by one particular organization. It is self-controlled and it is community-driven. That means you can rely on it to be here for a long time. And at the same time, a lot of these major companies have gotten behind Docker and are helping move Docker forward. So it still has the enterprise level support to configure them. After we do that, we're going to open up a new ASP.NET application and hook it up with Docker. And with that, we're going to understand how Microsoft does a Docker file. So you can kind of see the end result of a big Docker file instead of just our tiny ones we've created. And we're going to understand how it works with .NET and what the different pieces are in that, and even how to add Docker support later to an existing ASP.NET Core application. All right, after we do that, we're going to go to the Docker command line. Now, a Docker command line is where we build our images from our Docker files and where we run our containers, where we actually spool up and run a container. So we're going to cover what those different commands are and how they work, how to control the build and the run, how to work with volumes, which is basically where you attach from your host machine, you attach a file location so that a container can use that file location, but it stays on your machine. We're also going to cover additional information about Docker itself, how to get information about Docker, how to look at information about an image or a container to diagnose problems. And once we're all done with that, we're going to return to .NET, but this time, instead of letting Visual Studio create a Docker file for us, we're going to create our own Docker file manually and walk through those steps again so we can see just how we would build our own Docker file and maybe improve or change how Visual Studio does things and make it what's right for our environment. We'll set things up like making sure we're doing unit testing in our build, making sure that we're publishing just the published files and not our source code to the containers. So once all that's done, then we'll be done with this course, but at the end, I will talk through how do we launch the next step in your learning process, because we don't end here. There's more to come and there's more to learn, and so I'm going to try and focus you on here's where to go next to help in your learning path. But when you've gone through these 5 different sections right here, you will have a great grasp on how to use Docker in your environment and how to use Docker in your development and how to interact with Docker in the larger world. Okay? So let's talk about who should take this course. I mean, that's a great question to ask. Should I take this course or not? Does it affect me? And the answer is the first class of people that should take this course are web developers. Web development has been revolutionized by Docker. There's a lot of stuff in web development that can really be taken to the next level because of the fact that you can build your environment in such a way that it never changes and it's predictable. So web developers definitely should take this course. If you want to get into microservices, that's a big buzzword in the industry now. Microservices are almost exclusively run out of Docker. It's almost a requirement just because of how Docker works and how easy it makes deployment and development. Because we can bring down the entire environment or pieces of the environment with microservices, and we can debug on our machine in a production style environment. So microservices, almost a full-on requirement to understand Docker. If you're a DevOps person, even if you are a developer, but you have to deploy Docker or you have to manage your deployment of software, this is going to be a great course to know because it's going to help you improve your DevOps process. So, number 4, if you're a developer that has a test environment, and if you're a developer, you should have a test environment. So, if you're a developer with a test environment, then that's really important to know Docker because it's going to make your test environment that much more like production, which is always important for testing. Because if you test, but your test environment is different than production, then you're not going to find all the errors or the bugs. So your test environment has to be as close to production as possible. With Docker, it can be identical. And finally, if you work with .NET, you should take this course because Microsoft is really starting to push towards a Docker infrastructure with good reason. Docker has a ton of benefits, as we've seen earlier, and it's only going to grow. So definitely if you work with .NET, not saying that if you don't work with .NET you shouldn't, because of course 1 through 4 probably apply to you, but if you're working with .NET, you should definitely consider learning Docker. So if you fit into any of these categories, or even if you just want to stay current with the technologies being used in the industry, it's time to get started with Docker.